For question 3, a liquid mixture containing 30 mol% of benzene, 25 mol% of toluene, and the balance xylene is fed to a distillation column. The bottom's product contains 98 mol% of X, and there's no B, and 96% of the X in the feed is recovered in this stream. The overhead product is fed to a second column. The overhead product from the second column contains 97% of the B in the feed to this column. The composition of this stream is 94 mol% B and the balance T. Calculate the percentage of benzene in the process feed that emerges in the overhead product from the second column. And second, calculate the percentage of toluene in the process feed that emerges in the bottom product from the second column. So basically what the question wants you to find by the end of the day is to find the recovery of benzene and toluene at the final stage. So we will draw out the system. So this is a system. This system is like that. So you have your feed in. You have two columns. Okay, let's write this down. So you have your feed in, and also you have 30 mol% of benzene. So we will call that XB at F 0.3, and you have 25 mol of toluene XTF 0.25, and the remaining is X is 0.45. Let's call this stream N1. Let's call this stream N2, and then this stream N3, and this stream N4. Okay, we are given, the question has told us the bottom product contains 98 mol% of X, so we know that this is 0.98, and there is no B, so the remaining is T. X T at 1 is 0.02, whereas for the overhead product is fed to a second column, and the overhead product from the second column contains 97% of the B in the feed to this column. Right, so they did not mention the percentage of the component in this stream, but we know that there should be B, X, T2, and X, X2. Okay. The overhead product from the second column, which is here, contains 97% of the B in the feed to this column. The composition of this stream is 94 mol% of B and the balance T. So we know that you have XB3 is 0.94 and XT3 is 0.06, and we don't know what's the composition at the bottom stream in the second column. Therefore, we'll write it down. Okay, so basically this is the overall process. Let's call this C1 for column 1, C2 for column 2. So this is a multiple unit system, meaning to say you have two processing units in one process here. So how do you know which one you should solve first? Very simple. We can perform the number of degree of freedom analysis for column 1 and column 2. Okay, so we can check which one has a degree of freedom of 0, and we will start with the one with 0 first. So I have already prepared here. So for column 1, we have how many unknowns? So this is column 1. So we look at the variables around column 1. This we can put a basis. So we can put a basis of 100 moles. Okay, so the amount of unknown is, we do not know N1, we do not know N2, we do not know this 2. This one we can find because it is 1, for this one, 1 minus this 2. So we don't count this as an unknown, okay? And then we have 3 balances. We can do 1 total balance, material balance, which is F, N1 and N2, and 2 component balance, which is B, T, X, either 2 of them. Okay? Then we also have 1 specification, which was from the question. It says, "96% of the X in the feed is recovered in this stream." And this stream means the bottom stream. So we have that specification. So 4 minus 3 minus 1, our degree of freedom is 0. Whereas on the other hand, the degree of freedom for column 2, we have 5 unknowns and 2. Over here we have 2. And 3 and 4. And over here we have 2. Oh, sorry, no, we don't count this 2 because this will be solved in the previous question. And we have 3 balances as well, same as for column 1. 1 specification, which was given in the question again. The overhead product from the second column contains 97% of the B in the feed to this column. Okay, that is a specification. So our degree of freedom is 1. So how we are going to approach this is that we will solve the section where the degree of freedom is 0. When the degree of freedom is 0, means it can be solved. So once this has been solved, you will have the unknowns here since it is connected. For example, like N2, you have N2 here, right? So we have to solve this one for the N2, only then we can solve for column 2. Okay? So let's solve for column 1. First off, we have the specification given that 96% of the X in the feed is recovered in this bottom stream. Great, so we can do 0.96, 96% recovery multiplied by, let's put this over here, the bottom stream, multiplied by XF, and multiplied by the feed equals to, since it is connected to the bottom stream, so it is XX1. Okay, so you have the value for this, right? This is 0.45. This we have assumed a basis of 100. Next, this is 0.98, and you can solve for N1. Therefore, N1. Okay. Now moving on, we can perform a total material balance. So we already have N1, we have F. We can solve for N2. Therefore, total material balance F is equals to N1 plus N2. F is 100, N1 was the amount you have found in the previous solving, and then you can find N2. Moving on, since we have N2 and N1, we can do component balances for B and T. Okay, you can choose either one, but I choose B and T. So for B, the benzene material balance. So benzene, you have 1 over here. You don't have any benzene here, okay, that's great. And you have benzene over here. Therefore, it is XBF multiplied by F is equal to XB2 multiplied by N2. Similarly, this is 0.3, 100, XB2, we don't know, and N2 is what you have found above here. Then you can get your final value of XB2. For T, the toluene material balance. So toluene is over here. So you have XTF at F, and you also have toluene here, XT1 at N1, plus, okay, in is equals to out, yeah, XT2 at N2, XT2, okay, this one is 0.45, 100, XT1 at 1, 0.98, N1 was what you found here, insert it in, so you have this, XT2 is what you don't know, and N2 you also solve it from here already, so therefore you can solve for XT2. To solve for this, since this is a fraction, to solve for the, what is xylene, okay, to solve for xylene in the overhead stream from the first column, you take xx2 is equals to fraction, so 1 minus xb2 minus xt2. So from the previous part, when we solve for column 1, we have solved for N2 as well, and N2 you have it here. So this unknown is cancelled, right? That means you have only 4 unknowns. 4 unknowns, 3 material balance, and 1 specification. So your degree of freedom becomes 0. Therefore, you can now solve for column 2. Now, similarly, for column 2, you have a specification saying that the overhead product from the second column contains 97% of the B in the feed to this column. Right, so we have that specification. We can do material equivalence for this part. So you have 0.97 XB2 over here multiplied by N2 is equals to XB3 at N3. Therefore, you can solve for N3. This was solved in the previous part. N2 you have it as well, and XB3 is 0.94, right? and this one you don't know. Therefore, you can write entry. Then we can do total material balance again, which is in is equals to out, so N2 is equal to N3 plus N4. N2 is equals to N3 plus N4. N4. Solve for N4. N2, we found it previously, right, in the first part. So N2 over here is 55.92 moles. Insert it in. And N3 was the value you found here, and you can solve for N4. Moving on, we can do material balance for benzene. B, material balance. So material balance around column 2. B, X the feed here, here, and here as well. That means we need to solve for this. Same goes to your T, material balance. T, you have one here, and one here. You already have the specification for this. So xt2 N2 is equals to xt3 N3 plus xt4 N4. And you can find xt4. To find x at 4, same, 1 minus xt4 minus xb4. Okay. To answer the question for part A, we need to look for the overall benzene recovery. So what that means is that we want to know the amount of B over the amount of B coming from the feed. So to find the amount of B, that is 0.94 multiplied by N3, 30.95 over 0.3 by 100. And multiply by 100%, we should get 97% of benzene recovered from the overall system. For toluene, because the toluene one, the question asks the recovery in the bottom stream, so for toluene it is 0.892 multiplied by 24.96 over the feed at here 0.25 multiplied by 100%, and you should get 89% of toluene recovered from the bottom stream here.